this morning. So I think that shows the relevance of the concept too. And it's just as a comparison. Yesterday I looked and it was 20,377. By this morning, it had increased by 20 already. Of course, this Google Scholar, so there's also a great citation there.
You know what, Priscila? More than half of them say is bullshit. Which is also good.
I agree.
Are you one of them?
No.
Good question. In 2011, the same authors, or at least the same first author, he reevaluated and he got to the conclusion that they were worth 125. It's not that they gain value over time. The truth is that between these periods, we lost a bunch of ecosystem services. So they should be worth less. But also during the same period, we learned about other ecosystem services that we didn't know IMBeST. So we assigned value to these others, and that's why they're worth much more now. And this is much more than the world GDP per year. So we're talking about real money here that should be taken into account. And very quickly, when we want to assign value to the ES, I took the Spanish example here. It's coastal, but it's not necessarily because of the area. It's because they try to categorize many of the ecosystem services from agriculture to satisfaction for conserving nature, and they use many different methods to get to a price. So the traditional market-based and also the contingent valuation methods. Does anyone know what the economists here, do they know what the contingent valuation method is? Say. When you ask people how much they would pay to have that service, or when you ask people how much they would accept to give up a certain service. Okay, and then finally, in the last years, we've been paying more attention to the marine and coastal ecosystem services. That's really important since there's a huge interaction between land and water. Of course, it's mostly water. Most of the countries have a coastline, so we need to understand, we need to quantify, and we need to map these ecosystem services. Especially because, who here lives by the coast? So the others that don't live by the coast, who among those live by 100 kilometers away from the coast? Who doesn't fit any of these categories? 3 people in the room. So it's clear that we like to be by the water, okay? And of course that's because we also derive a bunch of benefits, but we also put a lot of pressure on the ecosystem in these areas, okay? But we still don't know a bunch of what's happening in these ecosystems. But with the first studies, we've been figuring out that some of the services, because there were already lists published on what the ecosystem services were, but they were for the terrestrial environment. And as we learn, we are adding some specific ecosystem services that are unique to the coast and to the ocean, such as coastal protection, for example. And the situation that we have for our marine and coastal environment, so not right now, in 2008, there was an estimate that 41% of the coastal environment and the ocean environment was under medium or high impact already, 0.5% very high impact, and these are the places where the situation is the worst. And if we need good ecosystem services, we need good biodiversity, for example, to keep species, for example. I guess somebody talked about this, or in one of the posters I see somebody that's exploring this, consolidate sediments, protect shallow shores and provide nursery and forage grounds. Kelp forests and coral reefs are an important source of food. And corals specifically, since there are so many people in the room who are interested in corals, they don't cover much of the ocean, between 0.1 to 0.5 of the ocean floor. But they have 1/3 of the marine fish species and 1 square kilometers of growing fish can support 300 people with no other source of protein. So we can't really neglect this kind of environment, okay? But the interest, it's taking some time for us, but it's growing the interest in our attempt to understand what's going on with marine and coastal ecosystem service. So this is a study published in 2013, showing that since 2006, people started caring about it. And more recently, a very famous researcher in this room did an update and showed that it grew a lot in the last years. So João is actually interested in the cultural coastal ecosystem services. So a lot to be done, because not many people have done anything about that. And these studies are rather concentrated in the north and in developed countries. So for those of us who are interested in the developing world, there's still a lot to be done. And it's when we need to, one of the things we need to do when we try to map ecosystem services is to try to understand that different ecosystems, if they interact in a negative or in a positive way. So in one of these first attempts to map, the study showed that a lot of the ecosystem services they have an interaction with, for example, food production have a negative interaction with the drinking water, with nature appreciation. Of course, like we don't, nature loses value if what you're seeing is a pork farm. But they also tend to be on the same place because the pork farm is going to be where there's water or where it's easy to have food for the porks. So that's a negative interaction. When the ecosystem services are highly correlated, we call it an ecosystem service bundle, okay? So where do we stand today? Officially, or internationally, there's been claims for us to map and understand the marine and coastal ecosystem service, so the conventional biological diversity, and other institutions have demanded that. The European Commission and the USA have specific plans to try to map these ecosystem services. And the way we do that is by trying to add all the science we have to deal with spatial locations. So we have the different shapefile layers with the information we need, just so we can plan the different uses we want for our oceans and for our coast. So do we want to have energy production in the sea? How is this going to affect shipping? How is it going to affect recreation, surfing, and fisheries, for example, and oil production? And one of the tools, so this is where I get to the part where it's not necessarily about modeling here, but about getting to know one tool to try to map these services. Let me just get this right. You don't have to use this tool in order to map ecosystem services. So if you're familiar with, if you're really good at GIS, just go ahead and do it different ways. So this is a way of making it easier, and it's called the Integrated Evaluation of Ecosystem Services and Trade-offs. It's a tool that was developed by the people in Stanford. And what's interesting about this tool is it's very interactive. So you define your goals together with your stakeholders. You map the situations, you map what you expect is going to happen if you change a certain ecosystem service amount, if you decide to use it more, if you decide to use it less, and you come up with the different scenarios. You show those scenarios to the stakeholders, and then you can reevaluate them and rethink the consequence of adopting or not certain scenarios. Today, so there are multiple modules inside the IMBeST. As for today, because they keep growing, there are 9 marine models: recreation, aquaculture, fisheries, coastal vulnerability, renewable energy, scenic quality, water quality, blue carbon, and habitat risk assessment. I'm going to walk you through 4 of these models very quickly. One of them is called Fisheries Production Model, and the whole idea is to predict catch and revenue of key species, and we want to know how we are going to have changes in catch and revenue if we adopt specific scenarios of development, for example, of increased fishing effort, of removal of a specific kind of habitat. If we change the legislation and we forbid fishing in different areas. It's very simple because it's a very fixed model. I'm going to talk about the limitations soon. So of course, if you know how to deal with more dynamic model, you can do it better than we can do here. But it's actually easy to integrate with stakeholders because they understand this in a simple way. So far.
No, it's crackling. The battery's going already.
Okay.
It's not you. It's just
It's
expand.
not you, it's the microphone.
Okay, but maybe if I talk a little further, it will be better.
No.
The battery's running out.
How about the pluggy one? Oh, yeah.
I guess it's not working.
It's the other one. The other one.
Oh, it doesn't matter because it's the microphone, not the.
Doesn't it? Just keep track, yeah.
Another one. So this, is it working?
Yeah, yes, thank you.
It actually sounds better for me. So if you don't know much about fisheries science, for example, if you can't really model species, this specific model of inVEST comes with a library for 4 species. But you have to pay attention that the library is specific for 3 different areas. Texas, Hood Canal, and then Belize. For these 4 different species, they already have all the data inserted there. And of course, we are not interested in these 4 species for most of our case studies. We're going to be dealing with the different crabs or different fish. And you have to run it for 1 species at a time. So that's also a limitation. But what's easy here is that if you don't know much about fisheries science, you can just play with certain aspects. Let's say you change the model by, if you know the longevity of your species and you know it's kind of similar to the white shrimp, you go there and change that. As an input, so for the 4 species, it already comes with all of that. But for you, if you want to play with another species, you're going to have to enter recruitment, age at maturity, migration, survival, and other aspects of life history of the species. For habitat, you have to say where the habitat is and the extent of each one. There is no information on the quality of this habitat, so that's also a limitation. And for fishery behavior, you have to put fishing pressure and market value of the processed catch. So let's say if it's a lobster and if you sell just the tail, you have to put information on the value of the tail of the lobster. As an output, you get as information catch, aggregate market value, value of habitats that support the species you are interested, and how changes in the availability of that specific habitat would influence the stock dynamics. So let's say that for the spiny lobster, you know that the species spend part of its time in the mangrove and then the rest of the time in the reef. You have to put the period of the time that spends in the mangrove, the size and the period, and then when it moves to the other parts of the habitat, to the different kind of habitat. And this is an example. There are others that have been published. This is the Belize case study. So they divided the coast in 9 different areas. And this is a catch this is for the lobster. The darker the area, the highest the catch. So you can see that some specific areas, most of the lobster come from specific areas, specifically the more central part and also the southern of the Belize coast. And here they model specific scenarios to discuss with stakeholders. One is the current scenario. What if we don't need anything? We just keep fishing the way we fish right now. And then for 2025. And how about we adopt a development? We're going to invest in more fisheries. We're going to increase fishing effort, for example. Or informed management. So it's not necessarily, we're not going to establish no-take areas along the whole coast. We're going to manage fisheries. And the conservation scenario, that's the more restrictive one. And then if you look at by each, so here you have each of the regions, and you have catch and revenue here, on the bottom and catch here on the top per region. So you see that the central region, which is already the most productive one, can be even more productive under an informed management. Of course, even more under a conservation scenario. But that may not be the best for some people. They might disagree with that. It might be harder to negotiate with stakeholders, a conservation scenario. And here you can see the details for each of the zones. If you adopt the conservation scenario, how much of the mangroves you're going to lose, how much of the corals, how much of the seagrass, because the conservation in this case wasn't necessarily no-take, accept that wrong, or the informed management of a development. So this is a tool for us to negotiate with people. There's some limitations already set, some of those, such as we don't include habitat quality. Fisheries assumed to take place at the beginning of the year before natural mortality. A species that has a specific phase of its development in the mangrove, if the mangrove is removed, that species collapses because we don't include replaceability in the habitat. Survival is not density dependent after recruitment. A market does not vary according to the harvest. And Rashid showed us in one of his first classes that that's not the case when you're talking about the report about the salmon. So like the market, of course, varies according to the harvest and vice versa. And this is the second model, the tourism and recreation model. It helps us predict why people go certain areas of the coast or of the ocean. So, like, if we take a look at this, this coast of the US, for example, I put this randomly, but let's say that people really like going here, or they like it even more going here and going here. And we wonder why people go to this specific place. But what's interesting is that a lot of people have actually modeled this through linear models, GLIMS, GAMS, whatever, and there is no single factor that explains why people go a certain place. If you look at one single area, it might be because the hostels are cheap there, or because they have nice pubs. It's on the coast and it's a party town, or because they have archaeological sites that are interesting. So multiple reasons in multiple places. But we want to understand the visitation rate of certain place, okay? And we usually don't have detailed information on the number of visits per area. So if we do have the number of visitors per area, we can easily model that. But when you don't, and we want to understand the factors and explain why people are going certain place, we can see, for example, we can predict the persons per day of recreation in space. We can use all of these predictors. And one way of doing that is by trying to understand where people visited the most. But how do we know where people visited the most? It's not necessarily easy, but that's when social media can help us here. So this model uses Flickr. I know Flickr is not that popular in many places anymore. Most people use Instagram, but in certain countries, especially in certain parts of Europe, people still post a lot of pictures on Flickr. So I've been following the forums and people have been asking the IMBeST people to really update and include Instagram, for example. But they basically...
What's Flickr?
Repository.
A different generation.
So it's their geospatial.
Yeah,
I only know that.
that's the best explanation. It's an old-fashioned Instagram. Like Panorama, for example, used to be too. Although Panorama is really cool, it's a pity that it was.
Welcome to the club.
Well, no, I did have Flickr. I would say I don't have social media in general, but I used to have Flickr. So, but there are countries where Flickr is still very popular. And it's a place that a lot of photographers go to because it's more like a professional place for pictures. So with what this program, what this module does, when you run it, it accesses a database, a world database, with all the flicker pictures. And it tells you the number of pictures that were taken on each of these grid cell here on a given day. So you can average this out for a period. How many pictures were taken in this specific spot over a year? And this gives us a visitation rate, even for places where we didn't have that information before. It may not be the best visitation rate, but I think that since people really like posting pictures, that's a pretty accurate one. So, Julian, getting back to your point, of course, there is a bias too, not only because it's Flickr, but also because a lot of the geotagged pictures are located in certain parts of the world. So that's also a problem. Not everybody will post pictures in the same manner as others. So the limitations are Flickr, the fact that the photographs is a browse for visitation, maybe it's not the perfect one. And it's a model that uses linear regression, and we know that the world's not linear most of the time. So there are ways of doing this better. And there's also a problem with the assumption because it assumes that people's preference do not change over time. So if the visitation in that area is explained by factor X, Y, and Z, in 10 years it will be explained by the same factors, which is not true. The third one is the nearshore coastal protection, nearshore waves and erosion. So we all know that the coast, different features of the coast work as natural breakwaters, attenuating waves, for example. In different habitats, will have different effects on attenuating waves, mangroves, marshes, and so on. So this is just an illustration of how it works. If you have a healthy oyster reef and a tidal marsh and the wave height comes as it passes through these habitats, it decreases its height. In the absence of these habitats or when you have less of them, then the height decreases less and there can be impacts on the communities on the coast. So this model comes with two different tools. The coastal vulnerability tool, which is in case we want to see the large scale patterns, noting of our vulnerability. Like for a whole area, what's the economic impact, for example, of having big floods. And this one, if we want details of what's going to happen on a specific part of the coast in terms of wave height. We need to input this kind of data here. The tidal elevation for the area, if it's a shoreline with, if it's a muddy shoreline, if it's a sandy shoreline, if there is a dune system, where the habitat is located, the extent it has, the density of the biotic habitats. If the area is storm prone, then we have to put the duration of the storms, wave height in general, and wave period. But we also need, this is very important, we need the social data here. So we need to know the number of people living in that area, we need to know where their houses are, we need to know the property value of those houses and of the constructions we have. So the more accurate information you have, the better result you have from your IMBeST. And if there's some management action going on, it can be positive like restoration or it can be negative such as habitat removal. And in terms of results, what you get is avoided, eroded and inundated area, the avoided number of people affected by flooded and avoided property damage. This is the kind of language that people really understand, politicians specifically. So again, the Belize case study, so this was a demand by the Belizean government. So that's why a lot of examples are done with Belize, because the government actually requested them to create different scenarios for adopting more conservative measures or more development measures. And again, a scenario for keeping business as usual, informed management, conservation, or development. So here you can see the first tool where we can see if we adopt informed management, how many billions we are going to save, of dollars, how we're going to save. And here is if we want a detail of a specific cross-section. We are seeing here the marshal of a specific region. The marshal is in green. And we're just looking at this little area here. So here we have the depth profile of the waves. Here's the Marshall. We see how much the height of the wave as it comes onto shore. And we see here, if we leave the Marshall, how the wave behaves. So when it gets to the Marshall, the wave height decreases really fast. If you remove the Marshall, the wave decreases not so fast, and that's where we have floods. And finally, the last of this is not necessarily a model per se, can be used with many different models. It's called the overlap. And I think this is really useful because this is where we can overlap different uses of the ecosystem. So let's say we want to know, we have to enter with the data of where human activities occur. So we have to say, for example, where aquaculture is happening, where fisheries is happening, and we have to assign weights of the importance of each activity. And these weights, so this is what we did for one archipelago in Brazil. We modeled, we inserted the weights of fisheries, so basically how much money was coming from every single cell here. So this is a protected area. Fishermen cannot fish here, but they are getting money out of different places. This is just an illustration. We did it for every single cell. And we also modeled here how much money the park was getting from recreation, from diving, from shark diving in different areas here. And this was done because the fishermen themselves were requesting, they wanted to know if fisheries were really important monetarily, because they thought, I think we make a lot more money than the park thinks we do. So if you can show them that the fisheries are really important to our livelihoods more than recreation, then maybe we can negotiate something. You can assign, so these are the ways. You can just say presence or absence. You're going to still have the model, you're going to still have the result. If you just say presence or absence, you're going to see where the activities overlap or not. If you assign catch or value of the catch or value of the recreation, then you're assigning an interweight. But you can also assign, say for example, well, fisheries does not make that much money, but it has a cultural relevance. And that's what we had to do in the end, because after we plotted the fisheries value, it was like more than 100 times less than the recreational value of the park. So the fishermen had no way to negotiate. But then, how do you assign a value for the cultural relevance of fisheries? So that has to be negotiated among different stakeholders, and that's not necessarily easy. This is the same model applied to the Chilean coast, the South Gate Coast, Patagonia, in the Chiloé region. They were exploring different scenarios, more aquaculture, more salmon growing to the fjords of Chile, and the effects on recreation, for example, allowing not only, so this is the aquaculture one, this is assigning more areas for the indigenous groups in the area, or keeping things, just to see where things would overlap more. And by seeing where things would overlap more, you could expect more conflicts between different activities. So it's a way of predicting where the conflicts will be if we let different ecosystem services be used in different ways. So I think the limitations is it does not model behavior, does not really assign value. You enter with developing the ecosystem service in this case. I already said you have to be careful with the weights, especially if you assign weights artificially, like the cultural value of fisheries. That has to be done very carefully because it cannot be true. But it's important as a negotiation mechanism. So you can go back to the stakeholder with your maps and say, this is what we have. There's going to be conflicts here in the future. Can we sit down and talk and get to a better solution, since we have to? Some of the uses will keep going for a while. And I think that's it. So there's a lot of online materials for if you're interested, just go. They offer online courses. You can enroll in one of these courses and learn all the modules of the inVEST tool. Okay, thank you.